Welcome, everyone. Glad to see you at our webinar on ENCY Hyper. I'm Andrew Levaigin, Channel Sales Director at ENCY Software, and I'll be your host today. Please drop a plus in the chat if you can hear and see me clearly. Great. People are still joining us. So, joining me is Elnar Galiulin, lead developer of ENCY Hyper, PhD. Elnar, please say hello to everyone.
Hello, everyone. Nice to meet you.
Thank you. Also today, we will hear from Robin Grijssen of the Belgian company CNC Solutions, our dealer and industrial partner. Kindly keep your microphones off during the presentation. There will be time for questions at the end, okay? I'm still admitting people who is joining right now. As always, some people are late, but no problem. So many of you have already heard about ENCY Hyper. We showed the beta version at ENCY World Conference and made a world premiere at EMO 2025 in Hanover. Now, this fall, we also have officially launching the product. Alongside the webinar, ENCY Hyper will get a dedicated page on encycam.com. I think this page is available since today. Plus, we're going to release supporting marketing and technical materials. Okay, let's get started. Before we dive into ENCY Hyper's details, let's briefly review the main methods of robot programming and how each of them addresses different production needs. The main methods are online and offline programming. We can also mention so-called text-based programming and the new trend AI-assisted programming. First, there is online programming or manual teaching. The operator moves point by point the robot using a teach pendant. It's simple, it's intuitive, but also very time-consuming. While the operator is programming, the robot stands still and produces nothing. Each new task requires stopping the cell, recording hundreds of points, and hoping everything runs smoothly afterwards. Next comes offline programming. Here, engineers create robot programs in a virtual environment without stopping production. CAD/CAM-based tools allow building digital twins, simulating toolpath, checking for collisions, and then sending verified code to the shop floor. This method eliminates downtime, but introduces another challenge, the gap between the digital model and the real world. When the virtual setup does not fully match the physical cell, manual corrections and recalculation are still required. Moreover, offline programming lacks direct feedback from sensor and the robot itself. Each of the mentioned methods has its own advantages and limitations. And this is where ENCY Hyper comes in. ENCY Hyper is our next generation software that unites all robot programming methods into a single hybrid platform. This is what robot programming with ENCY Hyper looks like in our office. Ilnar walks up with a tablet that costs around 250 euro, which is really cheap, creates a program, tests it, runs it, and controls the robot in real time. Fast, simple, and affordable. So ENCY Hyper is the software designed for touch interaction and visual programming. So you don't need to be a robotic expert to use it. ENCY Hyper provides real-time robot control and has access to the advanced trajectory calculation engine of a CAM system. Let's take a look at its interface. There are 4 main modes, each representing a stage of the workflow. The first mode, called cell mode, the robot cell can be created in Machine Maker our digital twin builder, and then load it into ENCY Hyper. Here you can edit the robot cell, add or modify components, and adjust layout parameters. Parts mode. In this mode, you define the parts. You can import a CAD model or build a parametric one directly. Then you set the grouping points and arrange the parts in the workspace, for example, on pallets or tables. Programming mode. You create your robot program visually by placing command blocks and connecting them in sequence. Once your sequence is ready, you can test it either in virtual simulation or directly on the real robot. Just press live. A safety slider on the right side, on the right controls motion speed. If you release it, the movement stops immediately. And the run mode. When the program is ready, switch to run mode to execute it on the real robot. Here you can control the speed, monitor the current tasks, and track the tool status, all in real time. All robot movements in the real cell are simultaneously reflected in the digital twin and displayed in the software interface. Now that you know what ENCY Hyper is in theory, let's ask Elnar to demonstrate the programming workflow in the system. Elnar, please.
Thank you. Thank you. Let me share my screen. Okay. Let me start from very beginning, from building a digital twin of your real cell. ENCY Hyper comes with digital twin builder. We call it machine maker. And building digital twin is quite easy. Just select robot, add some end effector, table or rotary table or rail, whatever, and put objects to correct positions. In Machine Maker, you will have access to thousands of verified pre-built objects from like robots, like rails, rotary tables from different vendors. Of course, you can also modify pre-built objects, changing kinematic schema or changing 3D models, and you can build custom robots. You can add custom mechanisms. After that, you can save your digital twin and use it in ENCY Hyper. ENCY Hyper has a very simple and clear user interface optimized for touchscreens, but for sure you can also use keyboard and mouse. As you can see, there are 4 different modes, 4 different application contexts, and first one is cell mode. In cell mode, you can modify cell created in Machine Maker and even add new objects. For example, you can add box, table, or even CNC machine. Let's add table. You can set table height like that. Okay. And when set table to the correct position, you can put the values here or move it interactively using these arrows. Let's move this table here. And now we can proceed to the next mode, it's parts mode. In the parts mode, you import 3D model from CAD systems. As you can see, we support different extensions, different CAD systems. I prefer using universal format like STEP or IGES. So just select 3D model, and that's it. Now, this 3D model is imported to ENCY Hyper, and we can use it for programming, for building our program for robot. For some kind of tasks like machine tensing or palletizing, a detailed 3D model is not so important. And for such kind of task, you can add parametric parts. It must be a parametric box or cylinder. Just put dimensions here. And that's it. Now you can use detailed 3D model or parametric cylinder. Let's put this 3D model to our table. Quite simple. We can also add it to an our table or fill the tray. And now we can finally go to the most important mode, to the most important tab, it's programming. ENCY Hyper is completely code-free solution, so you don't need to write code manually. You don't need even to know how cooker actually works, how robot actually works. All what you need to do, just add some simple blocks. We have a lot of different blocks, like moving commands, picking, placing, nailing, conditional blocks, and controlling inputs, outputs. You can even just open ENCY project and import toolpath from ENCY. Let's ask our robot to move like that. And when pick the part, I don't need to define position for robot for picking this part. I just ask robot to pick it. And when I can ask robot to put it to another table. That's it. Now I have a toolpath. If I need, I can change command parameters. For example, change save distance, make it a little bit bigger, okay, and recalculate the toolpath. Now I can start program simulation. I can simulate it in digital twin. On the right side of screen, I have a slider. So using this slider, I can control robot speed and pause it at any point. Okay, perfect. And the most amazing thing is what I can just hit with live button, connect to the real robot, and debug exactly the same program on the real robot. So it's not necessary to export toolpath, go to the robot. I can just connect it and control it directly from Hyper. Once when my program is ready to be run in production mode, I can go to the last mode, to the last tab, and start it in production mode. Here I can see the robot uptime. I can control robot speed. I can pause execution, resume it, or stop it. So it's a very brief introduction to ENCY Hyper. You can find a lot of examples here on the start screen, and for sure we will prepare a lot of how-to videos. And please feel free to use ENCY Hyper and give us your feedback. Thank you.
Thank you, Ilnar. It's amazing. Okay, let's continue. ENCY Hyper can run completely independently, and this makes it perfect for everyday automation. Think about all those common robotic tasks like pick and place, palletizing, packaging, assembly, or machine tending. Traditionally, setting up a robot for loading and unloading a CNC machine required hours of manual work. Defining every movement, fine-tuning grip positioning, synchronizing input-output signals, and adjusting timing. With ENCY Hyper, you can do all of this through a visual interface simply by dragging and connecting functional or command blocks. You define where to pick parts, where to machine them, and where to place them. It's so intuitive that even operators with minimum programming background can use it, but yet powerful enough for complex production environments. And here is something that sets ENCY Hyper apart from typical online programming tools. It includes automatic collision avoidance, a feature usually found only in advanced offline systems. You can work with robots from different manufacturers in one environment, switch between them, and visualize the entire process in 3D. You can debug and visualize the entire process. You can debug if we say in short, ENCY Hyper brings the power of professional robot platform to the hands of every operator on the shop floor. Take a look at this robotic assembly project. How much time do you think it takes to program something like this in ENCY Hyper? The answer is about 5 minutes. So it's really easy to use, very intuitive application. And as we already mentioned before, you can work with robots now without any knowledge of robotic programs or CAD/CAM software knowledge, which is really impressive. And here is a politicizing project put together by our dealer in Brazil, Comac. Previously, they used ENCY Robot software for such projects, which is not exactly a typical task for a CAD/CAM OLP system. But now, with ENCY Hyper, they have gained a lot of advantages: convenient debugging, high programming speed, and for sure flexibility. For example, if a box needs to be repositioned, the operator can simply move it to the correct place while standing right next to the robot. Here is another interesting project and unusual technology. It turns out that we can use a robot to drive nails. And as you can see, this robot is able to move along a rail. In general, you can program any number of external axes, something that is often missing in teach-pendant functionality. So projects like this, nailing, can be programmed quickly and efficiently in the basic configuration of ENCY Hyper. Let's move on to even more interesting things. We call this ENCY Hyper Max. In this configuration, ENCY Hyper acts as the operator interface, while ENCY Robot works in the background, handling heavy calculation and trajectory generation. ENCY Hypers is ideal for advanced applications such as robotic milling, welding, polishing, coating, or additive manufacturing. Let's take a look at how it works. A CAM programmer creates a project in ENCY Robot. The operator receives the project and combines it with other operation in ENCY Hyper. If necessary, the operator can modify technological parameters and recalculate the control program without involving the CAM programmer, or adjust the process flow by adding steps such as inspection, cleaning, or repositioning. So on this slide, you see the classical offline approach, where the program is fully prepared first and only then executed. In case of any issue with the setup, the program, mismatches, or other problems, you will most likely have to go back to the CAM system, recalculate the project, and then return to the robot again. So here is the loop. ENCY Hyper keeps the user in the loop with the real robot, allowing the program to be executed and refined simultaneously. In simple terms, the platform connects to the robot controller online, enabling the engineer to test and adjust robot motions directly on the real robot, while observing the results both in the virtual model and in the physical cell. This level of interactivity dramatically shortens the stop stage. Instead of the long cycle, simulate, export, test, go back to the PC for correction, the engineer in ENCY Hyper can fine-tune a trajectory or adjust the parameter on the fly and immediately see the effect. In essence, ENCY Hyper builds a live bridge between offline modeling and online execution. This hybrid workflow is especially valuable during commissioning. It allows flexible, human-supervised fine-tuning and debugging without long process interruptions. Here is a welding project with a rather complex multi-axis trajectory, and as you can see, ENCY Hyper is capable of handling that as well. Calibration has always been the most frustrating part of robot setup. You need the virtual twin to perfectly match the real cell. Every position, every angle, every fixture. If it's off even slightly, the robot can miss the part entirely. So here is the problem. In traditional online programming, calibration happens naturally. The operator moves the real robot by hand and records the actual points. But with offline or hybrid methods, you need to synchronize the virtual model with reality. And that usually means tedious measurements, touching reference points, and adjusting coordinates manually. ENCY Hypers make this process incredibly simple. When you run a test and see that the robot's real position does not match the virtual one, for example, the part is slightly shifted, you just switch to calibration mode. Then by moving the real robot through ENCY Hyper controls or teach pendant or even in zero gravity mode, you indicate the correct position. ENCY Hyper automatically adapts the digital twin to the real environment. It's calibration as it should be, quick, visual, and intuitive, directly integrated into the debugging process. On this slide, you see two examples of how ENCY Hyper uses a camera and just a web camera and AI-based object recognition. Instead of expensive scanner, a simple webcam is used, and thanks to AI, we get the same result as with a scanner. So it could be quite cheap solution with real feedback and with AI capabilities to recognize objects. As you already understood, ENCY Hyper does not require a post-processor for a robot control like a traditional CAD/CAM system. Instead, it uses a driver. Our team has already developed and tested drivers for KUKA, FANUC, and Dobot. These are available right out of the box. If your robot is not on the list right now, don't worry. We can develop a driver for it. All we need is the documentation and access to the robot for testing. However, right now, you can also order a software hardware option from our partner in France, Fuzzy Logic Robotics, which allows you to connect Staubli, ABB, Yaskawa, Universal Robot, and many, many others. So let's now answer the question, who did we develop ENCY Hyper for? First of all, of course, for robot integrators. It's a ready-to-use solution compatible with multiple robot brands. There is no need to develop or maintain custom software anymore. So you don't spend money for development. The integrator can prepare a project for the customer, and the customer can later adapt it easily without returning to the integrator. Integrators can design complete robot cells using components from a large online library, simulate process, and which is also very important for those who sell robots and software to demonstrate them to their clients. Robot manufacturers can bundle ENCY Hyper with their robots, giving customers a modern, flexible, and user-friendly programming solution, a strong value add. ENCY Hyper is a cross-platform application that can be installed on most industrial PCs, tablets, or even handheld computers. Robot operators and automation engineers will appreciate its visual programming approach. So easy to program now any industrial robot. No more complex teach pendants routines. Users can design complete workflows with simple drag and drop logic. ENCY Hypers ensures safety through full cell simulation and automatic collision avoidance. And for ENCY Robot user, ENCY Hyper becomes the perfect companion. It allows to fine-tune, test, and run ENCY Robot project directly next to the real robot without losing data or time. In this configuration, ENCY Hyper Max, ENCY Robot users can also take advantages of computer vision and real-time feedback from sensors and external devices. ENCY Hyper is a real product that you can purchase and implement in your production right now, today. So one of our industrial partner and dealers, the Belgian company CNC Solution, has gone further than others in working with ENCY Hyper. So let's hear about their real-world experience. I'll hand it over to Robin. Robin, please.
Hi, good morning, everyone. First of all, thank you, Andrew and Ilnar, for the excellent and very clear presentation of ENCY Hyper. So my name is Robin from CNC Solutions. We are the Belgian dealer of ENCY. We are also a machine building company. We focus mainly on milling, grinding, laser cutting applications with a Staubli robot. Mainly all the processes where you need high accuracy on the trajectories. I can't see the slides right now, but we can proceed in the slides if you can do so.
You want to see my slide, correct?
Yeah, if that's okay with you.
Sure.
Yeah. Yeah. Okay, you can proceed one slide. Okay. We developed a technology package where the Staubli robot is controlled by a back-of PLC, a motion controller within that back-of PLC. The technology package really bundles all the hardware and software to run G-code on the robot. So you can really use your robot as a normal CNC machine and execute G-code on it. We also offer this technology package to integrators who can then expand their this installation with their own hardware, software, and/or process. We use ENCY Robot to create these trajectories and then export to a G-code that then will be executed on the technology package. The programming of the trajectories is all an offline process, which is of course great because you're avoiding a machine standstill in that case. But as Andrew already explained, this has one big disadvantage, and this is that whenever something changes on the real machine, that the operator who is operating the machine itself always has to get back to the programmer who made the program. And then, of course, you're having machine standstill again. So in this case, ENCY Hyper comes to the rescue, and we can give more responsibilities to the operator himself and let them perform minor changes within ENCY Hyper, and they don't have to get back to the programmer, and the workflow can be continued. You can proceed one slide. In this case, you see a video. Since the early days of ENCY Hyper, we were very excited to create our own robot driver for our technology package. And in this video, you see our first test that we did with the robot driver. So we had to create some kind of driver that converts the motion data from ENCY Hyper to our technology package, so the robot can move together with the robot or otherwise. The creation of the robot driver was really simple. It's well documented, so I presume that most integrators or other dealers can program these robot drivers themselves, or they can of course rely on Ilnar and his team to create them for them. Can proceed. Another slide. Okay, and in this example, we show the demo laser application that we showcased on EMO. And you see on the left screen that our technology package where the machine is real time, ENCY Hyper is following the machine real time. So we mainly used it in the showcase, of course, as a digital twin. But we can also extend this to some kind of collision detector. We could easily send the data to ENCY Hyper, the future data. This means that ENCY Hyper is actually executing the movements that the robot will, for example, execute within 20 seconds. And if ENCY Hyper detects a collision on the virtual model, then it can put the machine in a feed hold state and really prevent collisions from happening on the machine itself. ENCY Hyper has a lot of potential for us, and we will certainly develop even more in our custom solutions. And we want to thank ENCY for creating this magnificent piece of software. Thank you.
Thank you, Robin. That's an impressive result. So what makes ENCY Hyper truly special? It's not just another robot programming tool. It's a new way of thinking about how humans and industrial robots collaborate. Unlike traditional methods, ENCY Hyper, traditional online methods, ENCY Hyper lets you program safely and productively while the robot keeps working. Unlike pure offline systems, it does not isolate programming from the real cell. You can adjust, calibrate, and improve on site. And unlike AI-only tools, it gives you full transparency and control. The human always stays in charge. So thank you for your attention. We are now ready to answer your questions. So you can write in the chat or turn on your microphone and ask verbally, please. Does anyone have questions?
Hey everyone, good morning. Well, it's at least morning for me.
Morning.
Quick question. With the camera app that you guys installed, is there a way to do some feature for laser tracking on welding for the deviations that are performed when you're doing laser tracking?
Elnar, what do you think?
Yes, sure. It's actually it's I think what we are working right now. We're working on it right now.
Alrighty, sounds awesome.
Thank you. The question is from Mohammed. Will ENCY Hyper replace ENCY Robot?
No.
No, I mean, in some cases, it can replace, for example, for pick and place and for machine tending, it can work, as I mentioned before, independently. So you can have only ENCY Hyper to program such tasks, correct?
Yes, ENCY Hyper doesn't replace ENCY Robot, but it extends ENCY Robot. For some kind of task, ENCY Robot is like overkill solution because you need a all CAM system for just picking part and putting it inside of a CNC machine, for example. For such kind of task, ENCY Hyper is much better when using not only ENCY Robot, but any CAM solution. So ENCY Hyper extends ENCY Robot, not replacing.
And the important thing that they could be connected, as we showed before. So you can so you can create a complex project in ENCY Robot and then export it to ENCY Hyper, and then you can be close to the robot and you can test, debug, and modify your project without coming back to a CAM software. That's a big advantage. Yes, please.
Hello, did you hear me?
Yes.
My question is how ENCY Hyper work in real robot cell with safety equipment, doors, guards, and so on. For example, if door is open, I can move robot or something like that.
Yeah, I think I got the question. In ENCY Hyper, we have access to inputs and outputs. So if you connect your door or any external device to a robot digital or analog input, you can just add input-output control block in your program. In this case, for example, you can literally build your program like that. If door is open, when don't move, or wait until door will be closed and when continue processing. So it's already work. You can do it, no problem. We have a success stories with controlling additional safety equipment. It works right now.
If we have some ready-to-use robotic cell which already work, but I would like to present customer ENCY Hyper, and should I then in ENCY Hyper write again this logic how a robotic cell work, or I could use logic from example from existing PLC?
You'll need to build with logic in ENCY Hyper, but it's not big deal because you can make it just in few minutes. It's not so complex.
Okay.
Yeah, I want to remind you that the programming in ENCY Hyper is just creating blocks by finger. Okay, so it's really easy. It's like a game. Okay, computer game. You just choose the command and place it to the correct position in a sequence. That's it.
Actually, you can also just add a macro block to a program and call some external macro, which is already inside the PLC if you want. In this case, you will see the simulation in ENCY Hyper, and ENCY Hyper will just wait while these macros will go to the end. So you can use the existing logic also.
Okay, it's interesting. Okay, thank you.
Thank you. More questions, guys?
Yeah, here.
Yes, please.
Is it right? I need the license for ENCY Robot, and with this license, I have ENCY Hyper, or can I program it with my test license for X Advanced? You understand me?
For ENCY Hyper, there is a separate license, and actually, there is separate license and separate distributive, correct?
Okay. Yeah, okay.
Yeah, it's separate distributive and separate license, but all of you can just install ENCY Hyper. ENCY Hyper will show you QR code. Just scan it, put your login and password from ENCY.com website, and you will get a trial license, so you can try it with no problem. It's just scanning QR code using your cell phone and authorizing in website. It's very easy. You don't need even to contact us. Just scan QR code and got your license.
Okay.
Or just visit encycam.com, and right now there is a web page about ENCY Hyper, and you can download trial version on the download section. So
it's
available right now.
Okay.
I have a question. More questions? Do you have more questions? No?
I see the question on the chat.
Yes.
After syncing, please. After syncing and running the program through the robot via ENCY Hyper once, if we're to run the same program next time, so we need, yes, ENCY Hyper works in real time. So ENCY Hyper controls next movement of robot. We are not exporting all program to the robot. We're controlling robot in real time. So you need to be connected to the real robot. It's not offline solution. It's hybrid robot programming. It allows us to stop the robot immediately if something goes wrong. For example, if your robot goes crazy or maybe something goes wrong, ENCY Hyper will detect it and stop robot immediately. It's the big advantage of ENCY Hyper. So yes, you need to be connected to real robot in ENCY Hyper. You can just export program to the ENCY robot or to your robot and go home. No, ENCY Hyper must be connected.
Thank you, Ilnar. Any questions? More questions?
Yes, I have one more. Now we speak about collision, and ENCY, that ENCY Hyper can detect collision in advance. Right, understand, for example, if we start a program with ENCY Hyper and how you say we can call external markers. Okay, I call external markers, and ENCY Hyper receive real state of robot position, and if robot goes to the collision, ENCY Hyper will stop robot before collision, or right on collision, or in which point?
It depends on the way we realize that. As Robin said, if ENCY Hyper will receive next commands, not current state of robot, but next position of robot, ENCY Hyper will detect it in advance and stop in advance. For now, by default, ENCY Hyper gets the current state of robot. Actually, before running on real robot, it's always good idea to check everything on simulation on digital twin. So you can check any collisions on digital twin simulation. But if you are using external markers, of course, it may be difficult. That's why we prefer to build all program inside ENCY Hyper. You will have much more control in this case.
Yeah, it is understandable. Just maybe it will be could be another advantage of ENCY Hyper as prediction of collision detection. If ENCY Hyper could read, for example, values in the advanced calculation of robots, I don't know.
Yeah. Your idea is quite close to Robin's idea, and I think it's totally possible, and we can do it, no problem. Actually, it depends on the robot driver. In Hyperside, it's very easy.
Okay, thank you.
Thank you. Any questions? More questions? If not, Elnar, can you briefly, we have 2 minutes, maybe say a few words about for the plans, about the drivers we're going to develop?
Yeah, sure. Next driver which will be developed, I think it will be Firina robot. For now, we're also looking at the ABB robots. And if you are interested on adding support of your robot brand, please feel free to contact with Andrew or with ENCY, and we will develop driver for you. And of course, you can do it by yourself. It's not a big deal. It just, it's just like one library. You must implement one C# plus, and that's it.
Thank you, Elnar. So thank you for your attention. So ENCY Hyper is already available for orders. The price now is very affordable for ENCY Robot users as a special moment. So thank you very much. So maybe tomorrow we're going to publish this webinar, and since next week, since Monday, we will spread out a lot of materials related to ENCY Hyper. Thank you for coming. Thank you for your attention. See you. Bye-bye.